Write a triangle part 3 for grade 8 English. In this lesson, we will recognize that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. This objective is the converse of Pythagoras Theorem. In figure 1 to the right, we have ABC is any triangle such that AB squared plus AC squared is equal to BC squared. Also in figure 2 we have M and L are two perpendicular lines at T. R is a point on M such that TR is equal to AB. Also S is a point on L such that TS is equal to AC. So we have M and L perpendicular at T, TR equal to AB, AC equal to TS. We have to prove that ABC is a right triangle. So our objective here is to prove that ABC is a right triangle given that AB squared plus AC squared equal BC squared and the given in figure 2. In order to show that ABC is a right triangle, we have to follow the following steps. The first step, we have to show that BC is equal to RS. We have to show that BC in figure 1 is equal to RS in figure 2. Let's see how. First, RST is a right triangle at T. So, we can apply Pythagoras Theorem. Since in any right triangle, Pythagoras Theorem is verified. What is Pythagoras Theorem? Hypotenuse squared is equal to the first side squared plus the second side squared. Where is the hypotenuse here? It is RS. It is the side facing the angle 90 degrees. So RS squared is equal to TS squared plus TR squared. But we are given from the beginning that ABC is a triangle such that BC squared is equal to AB squared plus AC squared. Now we have AC is equal to TR by given. AC, the distance from A to C, is equal to the distance from T to S by given. Also, AB is equal to TR by given. So by substitution, we get RS squared is equal to BC squared. How? Since AC equal to TR, then AC squared is equal to TR squared. AB is equal to TS, then AB squared is equal to TS squared. Hence, RS squared is equal to BC squared by substitution. And we know that if the squared of two sides are equal, then these two sides are equal. RS squared equal to BC squared, so RS equal to BC. The second step, we have to show that ABC and RST are two congruent triangles. So we have to show that this triangle and this triangle are congruent. How? By given AB is equal to TR and AC equal to TS. Also we just proved that RS equal to BC. Hence the two triangles are congruent by SSS. Side, side, side. Third step. Deduce that CAB is equal to 90 degrees. Deduce that the angle CAB, angle A in triangle ABC, is right. Since the two triangles are congruent, then by homologous elements, angle A is equal to angle T, then A is equal to 90 degrees. Fourth step. What is the nature of triangle ABC and justify your answer? From step 3, angle A is equal to 90 degrees, so triangle ABC is right at A. We conclude that if ABC is a triangle such that AB squared plus AC squared equal to BC squared, then ABC is a right triangle. So the rule is, If the square root of the length of the longest side in any triangle is equal to the sum of the squares of the other two sides, then the triangle is said to be a right triangle. This is the converse of Pythagoras theorem. Pythagoras theorem says that if we have a right triangle, then this rule is verified. Hypotenuse squared is equal to side 1 squared plus side 2 squared. Okay, what about the converse of Pythagoras theorem? If we have a side squared is equal to the sum of the squares of the two other sides, then this triangle is said to be a right triangle. Example. Here we have MNP is a triangle such that MN is equal to 9 cm, MP is equal to 15 cm, and NP is equal to 12 cm. Is MNP a right triangle? How do we check if this triangle is a right triangle or not? If the longest side squared is equal to the second side squared plus the third side squared, then this triangle is a right triangle. Where is here the longest side? The longest side here is MP 15 cm. So first we have to find MP squared. The square root of the longest side is MP squared, 15 squared, which is 225. Now we have to find MN squared plus NP squared. MN squared plus NP squared. The sum of the square root of the other two sides is 9 squared plus 12 squared, 81 plus 144, which is 225. Okay, what do you notice? We notice that MP squared is equal to MN squared plus NP squared. So, by converse of Pythagoras theorem, MNP is a right triangle at M. Application 1. Consider triangle ABC such that we have triangle ABC such that AB is equal to 7 cm, BC is equal to 4 cm, and AC is equal to 5 cm. Is ABC an isosceles triangle? An equilateral triangle? No. ABC is not an isosceles triangle nor an equilateral triangle. Why? Because we don't have any two sides are equal, so it is impossible to be an isosceles triangle. It is impossible to be an isosceles triangle, then of course it is not an equilateral triangle. No, since we don't have equal sides. Is this triangle right? And why? How do we check if this triangle is right or not? We can use the converse of Pythagoras theorem, which is the longest side here. It is AB, which is 7 cm. Let's find AB squared. AB squared is equal to 49. The sum of the square root of the other two sides is AC squared plus BC squared, which is 25 plus 16, which is 41. What do we notice? We notice that AB squared is different from AC squared plus BC squared. So can we say that this triangle is a right triangle? No, we cannot. Why? Since the converse of Pythagoras theorem is not verified. Another application, application 2. Consider triangle MNP such that MP is equal to 10 cm, NP is equal to 24 cm, and MN is equal to 26 cm. Is MNP a right triangle? And justify. So, to apply converse of Pythagoras theorem, we have first to search for the longest side. The longest side is MN, which is 26 cm. Then we have to find the square root of the longest side, which is 26 squared, 676. Now we have to find the sum of the squares of the other two sides. So MP squared plus NP squared is equal to 10 squared plus 24 squared, which is 100 plus 576, 676. So, what do we notice? We notice that MN squared is equal to the sum of the other two sides squared. we conclude that mn squared is equal to mp squared plus np squared, since 676 is equal to 676. So, can we say that m and p is a right triangle? Yes, m and p is a right triangle at p, since Pythagoras theorem is applied. mn is the longest side, then mn is the hypotenuse. So, m and p is right at p. We use the converse of Pythagoras theorem to check if the triangle is right or not.